And get started. So good morning, everybody. Thank you all for joining us today. My name is Sarah Abdi, and I'm the Marketing and Communications Lead at Parallel Flight. I'm going to be the moderator for this session, and I'm really excited to take this next hour to chat more with Joshua Resnick, who's the CEO and co-founder of Parallel Flight Technologies, and also with Matt Chasen, who's the CEO and co-founder of Lift Aircraft, about a new partnership to develop a hybridization solution for Lift's Hexa eVTOL aircraft. We're going to take some time to hear from both Joshua and Matt as they share about each company, and then we'll get into a discussion on the collaboration and where the two of them see the future of hybridization. At the end of the session, or towards the end of the session, we're going to have an opportunity for a Q&A. So I encourage all of you to please type in any questions via the chat box that you may have for Joshua and Matt. Do that at any point during the session. That way you don't lose your train of thought. And time permitting, we're going to do our best to get to all of the questions. Now, without further ado, I'd like to formally introduce the men of the hour. So just a quick background on both Joshua and Matt. Joshua brings a passion for groundbreaking technology and years of hybrid and electric powertrain expertise to Parallel. Prior to Parallel, he led system architecture and electrical engineering for the Tesla semi-truck program. Before moving to California, he led state-funded research for the state of Alaska, developing hybrid electric commercial fishing boats. When he was not designing the future, Joshua enjoys flying RC helicopters and hiking with his family. And Matt Chasen is the founder and CEO of Lift Aircraft. Lift's electric vertical takeoff and landing eVTOL aircraft, Hexa, is making the joy and utility of personal vertical flight accessible to everyone. While getting his MBA at the University of Texas in 2003, Chasen founded UShip, the first and largest online marketplace for shipping, with over 200 million in annual gross sales. Chasen studied mechanical and aerospace engineering at the University of Texas at Austin and was a NASA scholarship recipient. An engineer turned entrepreneur, Chasen was an engineer at Boeing in Seattle, where he worked on the F-22 fighter, airborne laser, and other advanced aerospace projects prior to business school. He is a pilot, an avid sailor, and a scuba diver. Matt lives in Austin with his wife and 2 children. So I am going to take this moment now to turn it over to Matt to get us started. Matt, I'm going to pass it over to you.
Great. Hi, Sarah. Thank you so much for that great introduction, and welcome everyone to this webinar. I'm really excited to kind of share a little bit about Lift Aircraft for those of you who aren't familiar, and then I'll introduce our plans for collaboration with Parallel and what that's going to mean for us. So I've got a deck to share with you all. Let me just pull that up here. I think you all should be seeing that now. Is that right? Are you all seeing the video? Okay, awesome. So Lift Aircraft, as Sarah said, was founded about 4 years ago, really to leverage new technologies that were developed for drones to be able to fly people and heavy cargo. So really the foundation for Lift is kind of recognizing that the situation with ground transportation, especially in urban areas, is really abysmal, as I think everyone knows firsthand. The average commuter in the U.S. spends 54 hours, not just driving every year, but stuck in traffic. That's wasted time. And the problem's only getting much worse as urbanization continues. So obviously there's a lot of work to try to reduce this type of congestion. Different ideas. Our thesis is shared with a lot of people, which is, we need to unlock the skies to enable sort of the third dimension for urban mobility. And that's now possible, actually, based on some recent technology developments, specifically kind of leveraging distributed electric propulsion, which is just multiple electric motors to enable sort of controlled flight, which is similar to the way small drones fly. And this is made possible in recent years by increases in battery energy density, and of course the core flight control and computer technologies that really born out of small drone use. And that over the last 4 years has resulted in the development of our Hexa aircraft. So Hexa is currently electric, but is a vertical takeoff and landing aircraft referred to as eVTOL by some. And Hexa is designed specifically to fit into a regulatory class we have in the US here called Ultralights. So Hexa has a single seat, which is part of the ultralight requirement, and is designed to be optimized for hover flight. So it doesn't have wings. It's not designed really for efficient cruise and long distance flight. It's really a short range, not optimized for high cruise speeds. But it's really good at what it does, which is safe and controlled hover and short range flights. So Hexa is actually already legal and approved to fly. There's no certification required for ultralight aircraft in the US under FAR Part 103. And we've been flying manned since 2018. So we have over 700 test flights. We've actually, we're one of the first eVTOL aircraft to enter production. We're ramping production of Hexa up now. And we actually have our first vertiport in development. So really quickly, some overall design features for Hexa. There's 18 motors, each with an independent battery pack positioned high on the aircraft to keep those rotors away from people. It also provides for good stability, having the payload below the rotor plane. Hexa has a ballistic parachute that autonomously deploys in the event it's needed. It can fly with up to 6 motors out. Depends which 6. If the aircraft at any time senses it has lost control, then it will deploy the parachute as a fail-safe. Critical to this type of aircraft, we have a redundant flight control computer. Our distributed battery pack system has a lot of advantages in terms of redundancy and weight savings. And the aircraft is amphibious, has actually 7 floats, which allows for safe operations over water. And we intend to start developing vertiport locations that initially will conform to ultralight operations. At which basically anyone, no pilot's license required, will be able to rent and train and fly Hexa. We have a VR simulator training program that is in the late stages of development. At these locations, we'll have our own sort of air traffic control and training programs. So controllers monitoring telemetry from the aircraft, instructors who can actually remotely assist in the event of an emergency. And these flight areas can be made safer and more controlled by geospatially mapping. So we can have the aircraft automatically avoid fixed obstacles, other aircraft, as well as keeping the aircraft within a safe boundaries, right? So outside of controlled airspace, and in designated flight areas. We will also typically only allow flights in acceptable weather conditions. So, these are relatively short duration flights on the order of 8 to 15 minutes. So the weather doesn't change much. So on good flight days, which is going to be most days, we will enable flights. But of course, if the winds are too high or there's a precip or other issues with flights, we simply won't fly. So that's a bit about the aircraft and about our sort of vertiport development plans. In the medium term, we do anticipate, allowing flights between different vertiports that we develop. And within the range of the aircraft, which is really up to 15 miles, we anticipate, setting up these routes in ways that they can be used for mobility. So, what this really will allow is an 8-minute, flight in Hexa replacing, a 15-mile drive. This example is a flight from San Francisco to Berkeley, California, across San Francisco Bay. It's an example of a potential route that one could fly. And there's an enormous potential time savings, with this new mode of transportation relative to driving. So we're really excited about, starting under Part 103 rules and then evolving in developing sort of what an operation that has utility for transportation as well. We recognize obviously that all electric aircraft have limited range and flight time. There are a lot of trips that are done by car today that are within the range of Hexa. So we're excited about the potential for the all electric Hexa, of course. In fact, 85% of trips that people take by car today are 15 miles or fewer, and 90% of trips are single occupant. So Hexa was designed single seat and short range. We think that has broad utility, but it does limit where you can fly. And so we do. We're super excited about working with Parallel to develop an extended range capability for Hexa. And what hybridization is going to allow is really pretty dramatically extended flight time and range. So we'll go from kind of utility for short hops or short flights to sort of a mid-range kind of flight time and range on the order of, going from about 15-mile range to somewhere in the 50 to 100-mile range. This means you could not just fly across San Francisco Bay from San Francisco to Berkeley, but you could fly from San Francisco to San Jose, which is almost a 50-mile drive that takes somewhere between 90 and 120 minutes in traffic, normal traffic conditions, and that's a flight you could do in around 30 minutes in a hybrid Hexa. So we're really excited for the opportunity to extend range, extend utility for Hexa. In addition to kind of recreation and transportation uses, we're also focused heavily on public agency use for these new types of aircraft. Law enforcement, search and rescue, firefighting, air ambulance services, and military as well. These are all uses for these new aircraft, again, enabled by technology that allows anyone to be able to fly. No special training is required, and in fact, no pilot's license is required. There is, however, a limitation on range, and many of these use cases will be significantly better served with a hybrid aircraft in extended range. So with that, I will hand it over to Joshua to get into the details of their technology and how it applies to Hexa.
Awesome. Thanks a lot, Matt. And I also want to thank the huge number of participants that are in this webinar. This is really exciting. And I'm personally really thrilled to be working with Lyft. I kind of fell in love with their aircraft as soon as I saw it, because I saw for a manned multi-rotor aircraft, they really solved a lot of the safety issues that I had seen with other platforms. And I also was very impressed with the redundancy that they had built into it, and the safety is really built into the design from the ground up. So I was super impressed. And then I was even more excited when I found out that the propellers were exactly the same ones that we were using on our aircraft. And I said, wait a minute, I think there might be some opportunity to collaborate here. So that's kind of where this started. And I'm gonna share a short slide deck, and then we're gonna get into what I hope is gonna be a lively conversation. So let's see, is that coming through okay? Can everybody see that? Awesome, okay, great. So we are Parallel Flight Technologies, and we are unmanned systems to save lives, property, and the environment. And the genesis of Parallel Flight took place up in the Santa Cruz Mountains in California. In late 2017, there was a significant fire in the mountains where my home is located. And there was also a massive fire up in Northern California in multiple places. So it was a bad fire year. And I started wondering, what can we do with unmanned technology to start attacking this problem? Because this is an exponential problem, and we can't approach it with linear solutions. We've got to find an exponential way to fight an exponential problem. And so I connected with the head of aviation for the Department of the Interior, Mark Baithrick. He subsequently became an advisor for Parallel Flight. And we talked about the different applications that were currently being done with drones, situational awareness, mapping, infrared, stuff like that. But what was missing were heavy lift, long duration systems that could bring supplies to the front lines of a fire, systems that could do large scale prescribed burns, and eventually systems that could put spot fires out. So my team and I went back to first principles, and we said, how can we build a super capable tactical multi-rotor that has long flight duration, can carry a heavy payload, is compact, and can start attacking these different problems? And so myself and some friends who are engineers came up with the parallel hybrid solution. So the fundamental issue is that when you're talking about electric multi-rotor drones and you fill them up with a heavy payload, you're only going to fly for about 15 minutes. And this limits your application space. So how can we expand this? Well, hybridization. The problem with existing hybrids is that they do really good at extending flight time, but they're not very good on the payload side. So we really wanted the best of both worlds. So we developed this parallel hybridization, and this is a totally new way of hybridizing. There's a gas engine and an electric motor on every single rotor of the aircraft. And if any one of those gas engines fails, the other rotors can supply electrical power to that failed module, and the aircraft can continue to fly. So this has this same redundant architecture as the Lyft platform has electrically, we have it in hybrid form. And this means that you don't have to carry large backup batteries around with you. So it's one of the advantages. It also has a much higher conversion efficiency. So there is a certain amount of energy in the fuel in the aircraft. And by doing parallel hybridization, the engine has a direct mechanical connection to the propeller, and you end up with a high conversion efficiency because you don't have to go from gas to electric and then go back to a motor and then spin the prop. What you end up is with a system that has the agility of an electric motor, so it has very high instantaneous torque, but it also has good continuous power. So all of that makes the system very, very capable. Our aircraft has 100 pounds maximum payload, and it can fly that for 100 minutes, 50 pounds for almost 200 minutes, and 10 pounds for 215 minutes. So this is a super capable aircraft, and when we talk about payload, I'm talking useful payload, not fuel payload. This is the actual payload that you're strapping to the aircraft. The markets that we're working in are firefighting, healthcare, and industrial logistics, and these are all relatively big markets. The industrial logistics market is 65 billion. The healthcare is 20 billion, and firefighting is 10 billion. And I'm just gonna hide this real quick. All right. Is my screen clear? Or does it have blocks covering certain parts of it?
You're clear.
Okay, perfect. Great. Just want to make sure everybody can see everything. So we're working in these different markets. We're extremely excited, especially on the firefighting side. And I think the next slide should speak to this. Yes. So we're the recipients of, at this point, 4 federal grants. We've received funding from NASA. We've received funding from NSF and from the USDA. We're currently on a phase 2 SBIR grant from the USDA. And this grant is to demonstrate large-scale prescribed burns. This is becoming a really big deal in the Western United States. Prescribed fire is a tool that has been used for centuries, if not millennia, by indigenous peoples. And it's a tool that is gaining more and more momentum now as a way to clear fuels from forests so that when fire comes, it's not catastrophic. And because there's been a long-standing policy of kind of extinguish fires as quickly as possible, we've ended up in a situation where there's basically 100 years of fuels that have built up in these forests. It's one of the reasons that we have such catastrophic fires. So by doing controlled burning, you can remove those fuels. And the challenge has been that controlled burns can be costly, and they're also very dangerous when they're done by helicopter. A number of helicopter pilots have died doing controlled burns because the helicopter is flying in the so-called dead man's curve. It's that low and slow part of the flight curve that if you have some kind of mechanical failure, there's really no room to recover. So these burns are starting to be done with drones. However, the drones have the same limitation of all electric drones, which they can only fly for about 10 or 15 minutes with their payload, and they're also quite small. We're working with a partner company to scale this up, and they're building the payload, we're building the aircraft, and the USDA is funding this, and the target is to be able to build an aircraft payload combination that can do 1,000 acres per flight. And so this will lower the cost and increase the safety of prescribed fire. And California has just passed legislation expanding the scope of prescribed fire and increasing the protection. Oh, and it looks like I was just given a notice from one of my engineers that I misspoke, that our platform will be capable of greater than 2,000 acres. So, and of course that depends on the weather conditions. We can do these operations at nighttime in zero visibility. We can see through smoke directly with our infrared cameras. We can fly by GPS, and it's one of the benefits of these uncrewed systems, which is that they can do the dull, dirty, dangerous work that we just don't want to put pilots into. So these are some of the applications we're excited about. These are the funding sources that from the federal side that have been supporting us, and we're really excited about all of that. There's a lot of synergy here between these unmanned systems or uncrewed systems that we're building and the eVTOL or electric vertical flight systems that companies like Lyft are building. We can hybridize them and increase their range. we can give them a lot more capability, especially for military applications, public use applications like firefighting. We had a big event yesterday with a lot of our customers, and a number of firefighters were sitting in a room together, and I was telling them about this collaboration, and they got very excited and said, we would love this system to be able to fly autonomously, land, and then a pilot, or then not a pilot, a firefighter who needs to get airlifted can hop in and get extracted out of harm's way. There's been, a number of fatalities over the years. Firefighters can get trapped. Having a few of these vehicles on hand, ready to go extract people, would be it would be totally game changing for wildfire, as one example. So we're really excited about this collaboration. The core technology that we have, our core IP, is this parallel hybrid electric multi-rotor, or FEM. We can take our hybrid power modules and essentially replace the battery motor combos that are on the existing Hexa platform. The beautiful thing about this is that, if any one module has a failure, unlike a helicopter flying in that dead man's curve, the aircraft can keep flying. And it also has a very large dynamic range because of that electric component. You get that instantaneous torque to give the aircraft a lot of maneuverability beyond what is normally seen with a small helicopter. This can extend flight time exponentially. We can scale it to kind of n number of rotors. In this case, we'll do 18 rotors, but future platforms maybe will have smaller number of rotors and bigger modules. You can do different configurations for different geometry aircraft. There's a lot of flexibility here. So we're estimating for the crewed version of Hexa 1.5 to 2 hours, oops, skipped a slide, of flight time with the hybridization. There's still a lot of analysis and work that needs to get done. We're just kind of at the beginning of our collaboration together, but this is kind of our initial pass at simulating what the flight time will look like. For the uncrewed version, it would be 280 pounds of payload. This will be, again, with 18 modules, and in this case 42-inch propellers, so slightly larger than what Lyft is currently using. And I'm sure Matt will speak more to this a little bit later about the modular aspect of Hexa, that it can be it can fly people, or it can be swapped for cargo. So I'll wrap up my talk here. The last thing I want to say is that both Lyft and Parallel Flight are currently raising via crowdfunding on Start Engine. We've raised over $8 million via crowdfunding since our inception. So we're really thankful to all of our investors. We'll talk a little bit more about this at the end. We'll get to some of the questions, but we certainly encourage everybody to visit our offering, as well as Lyft's offering on Start Engine. So with that, I will stop talking and we will start taking questions.
Awesome. Thank you both, Matt and Joshua. And so one thing before we start an open discussion, I'm seeing a lot of great questions come in and a lot of questions in the chat. So just make sure that if you want your questions answered, to be putting them in the Q&A box, because I'm seeing some good chat going on, but also some questions mixed in there. So I am going to start off with our first question for Matt, and I think this will be a really good starting point. So why did Lyft choose to work with Parallel?
Yeah, so like Josh alluded to, he and I met by phone, I think, right, like in 2020, I think, Joshua, it was. And, we're looking around at various ways to potentially have an extended range version of Hexa. And there's a lot of different technologies out there. There's there's fuel cells that, of course, we considered. There's different sorts of gas-powered generation, sort of range extension. There's a serial hybrid approach, and then there's this parallel hybrid approach that Parallel is named for. And it was right as I was sort of digging in and understanding the complexities of the different approaches that I met Josh, and we hit it off instantly because, like he said, we actually we're prototyping using the same motors and propellers. And so we were right at that same power range. Of course, they have a quad with 4, we have 18. But, we said, oh my God, and I was actually blown away by the technology that they've developed. This is really hard stuff. You could ask us, why don't we just like do this ourselves? This is really hard stuff. Joshua and his team, they're experts at this. This is really complicated. They're on, I don't know how many different, this is probably version 5 or 6 of their prototyping, and they're improving it. And they've been doing this as long as we've been creating our manned aircraft platform, just focused on this one problem. So they're excellent at it. And we decided we've got a lot on our plate. We're not just designing aircraft, flight testing aircraft. We're in production now with Hexa, and we're rolling out vertiport locations and training pilots to fly. We are not big enough to be so deep into each piece of tech. So it was just a wonderful coincidence that we met, that we're using, as a matter of fact, we're using the same redundant flight controller as well. So we just said, look, when the opportunity arises, let's collaborate on seeing what your tech can do for Hexa. Now, that said, we are still, this is early in this collaboration, and it's very exploratory. So we're also looking, at other different types of, range extension technology, but this appeared to us as the most promising. And so we're taking this first step toward, assessing it further.
Yeah, I was also really excited when I saw that we were using the same flight controller, because it just makes that electronic integration that much more seamless, and also on the simulation side as well.
Yeah, definitely. And I think this is a great segue into the next question. Joshua, maybe you can speak a little bit more to the timeline for this project with Lyft.
Yeah, so we're looking at 12 to 24 months to develop essentially a high fidelity proof of concept aircraft. Hopefully something that will be useful as a tool right out of the gate. But with all of these with all of these projects, there's usually some iteration that has to happen as well. However, I've been super impressed with Lyft's ability to design an airframe out of the gate that was essentially worthy of production. So I think the two companies working together can come up with something that'll be useful right away. Yeah,
definitely. I think Kurt on the chat just said it great. He said that this is a great marriage. So it's a good synergy between the two companies. Let's get a little bit more technical, Joshua. So how does the hybrid power system work?
Sure. Yeah. So let's start with kind of first principles, where if you think about a gas engine, if you want to accelerate that engine, make it go faster, you've got to open the throttle up, which is a mechanical process. And then there's inertia. It takes time for a few cycles of combustion for the torque to increase. So there's this lag. Well, in an electric system, in an electric motor, the second you apply electric current to those coils, you have instantaneous torque. So when you talk about a multi-rotor aircraft, the way the aircraft maneuvers is by accelerating and speeding up and slowing down the propellers. So you need that electric motor to do that. You need an energy source that's very energy dense, and in this case, it's liquid fuel. So You've got the combustion engine to provide that. We have a proprietary system. This was actually designed by part of the design was done by a fabulous engineer who's done nothing but design helicopter gearboxes for the last 40 years, a very experienced fellow that worked with us, and we've developed our latest generation hybrid power module. We're really excited about it. It's got a lot of unique technology in it. It combines the electric motor and the gas engine, and in a very unique way that allows that instantaneous torque as well as the baseline power from the engine. It also captures the recuperated thrust from the cooling of the engine.
Uh-oh, did Joshua freeze, or is it just
that we have electronics that are monitoring the system continuously, and if we see any deviation from the expected performance of either the gas or the electric motor, it's able to actively switch between which is providing the power. As Matt also said, we've been developing this for 3 years. It's highly non-trivial. We're really excited about the version of our power module that's going into production. And we'll be releasing more information about that in the next couple months, which we're super excited about.
That's great. And so another question, that piggybacks off of this more for Matt is, with this hybrid system, are you still expecting Hexa to be ultralight?
I think hitting the ultralight weight limit with these extended range power modules is going to be challenging. We're exploring that possibility as part of this partnership. I think there are other configurations that we may also explore, different numbers of rotors, different layout. I think the important thing is, there are a lot of use cases. Josh mentioned several already, military, firefighting, for which the ultralight qualification just does not matter, right? Those public agencies using aircraft do not need to comply with FAA aircraft classifications. So there's great opportunity in public use markets, for an aircraft, despite potentially not qualifying as an ultralight. We also plan to develop a certified version of Hexa, and this may well be the powertrain that we use for that. When you go up the next class of aircraft, sort of up in terms of weight from ultralight is light sport. Now this actually the light sport regulations are in the process of being rewritten. That gives you a lot more flexibility in terms of the weight of the aircraft, like 3 to 5 times heavier, and it allows you to have 2 seats instead of 1 seat. So we, Hexa is our first aircraft. It's a very specific, focused, all electric, short range sort of application. I think as we introduce hybridization, we've got to look at, how does that map to different aircraft classifications, and then some of which may require certification, right? Which, does take some time.
Yeah, that's great. And you just, touched a little bit on how this hybridization can open up to, 2 passengers instead of 1. Do you foresee extending beyond that as far as passengers?
Our strategy is we're kind of working from small to big, and in our view, one of the most efficient ways for 2 people to fly is to just fly 2 aircraft. When you start adding people and payload, the power requirements and the cost of the aircraft, these things don't just go up linearly with the number of people, it goes up exponentially. So At a certain point, it's better, to just separate out into different aircraft that can be lighter and simpler. So with that said, I think we are thinking about and have some preliminary concepts around a 2-seat model that would conform to a different aircraft class, but that's years away.
Sure. I mean, and this next question, maybe for both of you, but noise levels, with the hybrid version, what can we expect there?
Yeah, so I think initially, for the first pass, it'll be fairly loud, but we're working on some really great technologies with a partner that develops 3D printed mufflers, and this technology has been demonstrated where the sound of the combustion engine is not louder than the sound of the propeller itself. So while I don't have an exact decibel number to give you guys, I can say that we're on a path to making this surprisingly quiet for a hybrid system. It'll be less, it's not just decibels, right? When you're talking about noise, it's also the frequency spectrum. If you think about a turbine, it's got that high pitch whine. This won't have that. It's a lower frequency noise. And with the kind of advanced muffler technologies that we're looking at, we believe that it's going to be very manageable. Also, because you've got a larger number of rotors, not these, very, like if you think about a helicopter, you've got these essentially two blades, right? And every time they pass, you hear that shock wave from the blade, and you get this loud thump, 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 thump. With this system, you don't have that. You've got a lot of blades that are whirring, essentially. And again, it kind of splits that frequency spectrum up. There's also some really advanced technologies that we're excited about that I think are really well suited to Hexa, where you essentially dither the speed of the rotors. And what that does is you don't have a lot of rotors that are all spinning at, say, 3,000 RPM. You spread that out, so you've got a range from, say, 22,750 to 3,250. By doing that, you make a broadband frequency range, and that has been shown to drastically reduce the acoustic signature. So I think there's some really unique technologies that are available to reduce that signature. And like all technology, it's going to take some time to develop, but I think that when we get there, it's going to be really good.
Yeah, I'll add on real quickly to that. The comp here is helicopters, right? And helicopters are fantastically loud machines, right? You have three sources of noise: the main rotor, the tail rotor, and the engine itself. And each is at a different frequency. And like Josh said, it's really, it's not just loud from a decibel level, but the pitch and the type of noise is annoying. So people don't like helicopter sound. When you go all electric, you get rid of two of those noise sources, right? There's no tail rotor, and there's no engine driving it. The motor is virtually silent. You do have the prop noise, which is not nothing, but we're talking like an order of magnitude quieter than a helicopter. When you add in the hybrid, in my view, we're going to work on exactly what the noise signature is, of course, as part of this collaboration. But I think you do add in substantial noise, but I think it may be like 2x the noise. So you go down 10x from a helicopter, and it's going to be on the order of just a small multiple of the noise to add in the hybridization. But it's still going to be just dramatically quieter than helicopters.
Great. And leading us to the next question, I think, more for Josh, but Matt, feel free to take a stab at it too. What type of gas or fuel should we be expecting here? So like a 50-in-1 mixed gas? Is it straight gas with a standard 4-valve system? Maybe you can talk on that.
Sorry, it's the mantra of 2021 and 2022 is you're muted, right? I'm unmuted now. So the gas that we are using currently is gasoline with two-stroke oil. Now, this was chosen specifically because firefighters have that on hand already for their tools. Going forward, we're looking at a number of multi-fuel options. One thing that's really important to me is making the system green. And for, when we're doing, I would say non-critical, non-emergency operations, I really, really want to focus on our systems running on ethanol, especially. It's a great substitute for gasoline. And there are some, really new plant-based fuel streams that are ethanol, that are based on plant waste, that are proving themselves to be carbon neutral. So I'm excited about collaborating with some of those supply chains for ethanol for a lot of these non-critical applications. Again, for firefighting, they want to use gasoline and two-stroke oil because it's what they have on hand. For military operations, Jet A is the fuel of choice. And so we're looking at a number of different multi-fuel technologies for our engines. And we're excited about integrating those. So one of the nice things about our hybrid power module system is that it is exactly that. It's modular. So it's essentially agnostic to the type of engine that you use. And so we can find the best engines to use, and that won't require any fundamental change to the airframe or anything else.
Yeah, that's great. And so a little bit more on that. And what about CO2 emissions?
Right. So there's going to be emissions, for any non-carbon neutral fuel, but that's why I'm really excited about looking towards, as green a fuel as possible. Like I said, ethanol is very promising for this. So, yeah, we want to keep this carbon neutral whenever possible.
Sure. Matt, so talk to us a little bit about should we be expecting any other changes to the aircraft with this hybridization?
I think it might be too early to tell. If the ultimate final weight of the modules for our application wind up requiring a different layout or a different number of motors, right? That trickles its way down. Our entire aircraft is tuned and specifically for our exact weight and payload. So it could. We're trying to develop a version of this that might even be swappable with our current powertrain. Hexa, as Joshua mentioned earlier, it's modular by design, so that the top rotor crown that you see, actually the cabin and the legs, everything below that is payload. It's held onto there just with several bolts. So we can literally unbolt an all-electric crown if needed, and hopefully attach a hybrid crown, or conversely, you can detach the passenger cabin, the pilot's cabin, and then replace it with a cargo attachment, a cargo module that is designed with a rack system that we're developing for carrying cargo instead of people. But that top crown section is modular, and we hope that the hybrid version will be a different module for the powertrain.
Great. And a question, this is always a good one for both of you. What kind of challenges do you foresee overcoming? Obviously there's a lot of that in tech, so.
Yeah, I mean, I think that it's a complex engineering project, and from my perspective, PFT has solved the key architecture here, first of all, on the electronic side, the modularity is something that we've demonstrated. We know that it's scalable, but it's essentially work to make that happen. So, there's certain board, printed circuit boards, electronics that have to get developed, flight controller integration, simulation, because whenever you do a project like this, you need to simulate first to work out all the bugs. It's called hardware in the loop simulation. It's a sophisticated type of simulation that we've done a lot of work with. I know Lyft has worked on this as well, but bringing that together so that we have our hybrid electronics running on one end of the simulator with the flight dynamics for Hexa on the other side, making sure all that works. So I don't see any like fundamentally scary challenges. I just see engineering work and kind of taking the stuff we've developed to the next level.
Great. So I want to kind of pivot here because I'm seeing, a lot of questions, that are a little bit more about the raise of each company. So before, I do that, let's see here. Okay. We'll go with this question for Joshua and really for both of you. Can you speak a little bit more about your IP and your IP strategy?
Yeah, sure. So we recently had one newly issued patents. We have a number of provisional patents and in the pipeline and others that are going to be filed as full applications very shortly, as well as internationally. We have patents that are pending. So we're working on IP around our core tech and core applications. So making sure that all of that's covered is key to our strategy. Great.
And I'm actually, with that said, I'm gonna launch a poll out to all of our attendees. I see a ton more questions coming in on this topic, but it would be great if everybody can answer. And so, then I will jump here to the next question on that topic. For both of you, is Parallel Flight going to be holding an equity position in Lyft aircraft?
Yeah, I'll take that, Joshua. Yeah, this initial partnership is the start, we think, of a great long-term collaboration. It is the first step, and there's there's no equity swap, or there's nothing formal in terms of an investment by either company into the other at this stage. Obviously, if things work really, really well, that's could be highly strategic to one another to have this. Parallel is going after a very specific market and a very specific payload range with their aircraft, and it's a great opportunity. If you think about small drones or the small size, I would say Parallel's Firefly is kind of the medium size, which is really, for a drone, it's huge, right? A 100-pound payload is fantastic. Hexa then I think is the large, right? It's got many more motors, heavier payload, up to 300 pounds, 350 pounds in a cargo configuration. So there's a lot of different applications, and there's just a huge market for moving heavy cargo and pilots by this new tech. So I think both companies have a fantastic opportunity ahead of them individually, and this partnership I think helps both parties.
That's great. Okay. So this one's for Joshua. And again, a little bit back to the technical side. Are you considering using FEM and fixed wing drones for heavy payloads in industrial logistics? Talk to us a little bit about that.
Yeah, it's definitely something that's on the horizon for us. That's a fantastic market. Those airframes are technically very challenging. I believe there's a lot of things that our parallel hybrid technology can do in a fixed wing vertical takeoff or short takeoff and landing configuration. So yeah, it's something that we're looking forward to. Our focus right now, though, is pure vertical lift. There's a big market there, and there's a lot of applications and use cases. And also, those aircraft are simpler to build. They're more modular and in a lot of cases more compact. So we're focusing on that right now, but certainly plan on doing those other types of missions down the road. I think we're getting toward the end of our hour, and I want to make sure that both Matt and I have a chance to talk a little bit about our raises. So Matt, do you want to kick that off, talk about your raise, then I can talk about mine, and then we can wrap things up?
Yeah, happy to. Yeah, no, we're excited to be offering, the opportunity to invest in lift aircraft out to the general public through what's known as Regulation CF. We've launched a raise through the Start Engine platform. This is to complement and augment venture capital that we've already raised. But we've over the years had a number of our fans, our community, who are interested in flying, who have also asked how can they invest in the company. And so there's great, relatively new sort of regulations that allow anyone to invest in private companies really at scale. And so this is a kind of a trial for us. This our Reg CF raise is a $5 million raise. I think we're $3 million into it. I think there's obviously the opportunity for a bit more. We're going to see how that goes, and I know there's the ability to raise even more through Regulation A+, and so we're considering seeing how this works, and we'll play by ear if we decide to raise more.
Awesome. Yeah, I'm really excited to see Lyft on the platform on Start Engine. As a lot of our audience knows, Parallel Flight has raised a lot of money with crowdfunding. This is our third raise on Start Engine. We also had a small Regulation D raise in there. When you add it all up, to date, we've raised over $8 million through crowdfunding, and that's been augmented and supplemented by federal grants. This new raise we just opened just a little bit over a week ago, and we're just at about $300,000. So it's going well. It's off to a good start. I'm really excited about it. It's going to fund a tremendous amount of flight testing and essentially module testing over the course of this year. It's going to fund the beginnings of all the work that we need to do on the certification path for the US markets. And it's also going to fund the development of a number of prototype aircraft that we're going to be beta testing with some of our earliest customers. So the funding is supporting a number of different strategic initiatives. There's also institutional investment that's coming in as part of the round. In fact, a VC firm from Alaska just invested with us as well. So we're very excited about that. And yeah, we're thrilled to be raising with crowdfunding. I've kind of said this from the beginning that we believe our company is a public good company. We're very dedicated to public good applications such as firefighting, search and rescue, and disaster relief. So I believe that it's important for the public to have a stake in these companies and not just institutional investors, though the institutionals play a big role in being able to provide some of the larger amounts of capital that are required for aviation companies. So anyway, I'm thrilled to have this available to everybody. And Matt, this has been great. I've really enjoyed chatting on this call and enjoyed all the work that we've done together so far. And I'm looking forward to all the next steps.
Likewise, Joshua. This is great, and yeah, we've got a lot of work to do together to make this vision come true.
That's right.
That's great. So again, I just wanted to thank everybody for attending today, and thank both Matt and Joshua for a really great discussion. I know there were a lot of questions that we didn't get a chance to get to. So in the coming days, keep your eyes peeled for a detailed FAQ that we'll put together to answer some of these ones that we didn't get a chance to get to. And if you're not already doing so, I really encourage you to follow both Parallel Flight and Lyft on all the social media channels: LinkedIn, Facebook, Instagram, Twitter. Check out our Start Engine pages. You can keep up with the latest news and updates there. And if anybody has any follow-up questions, please feel free to reach out to us. But other than that, I'll close this session and wish all of you a wonderful rest of your Wednesday. Thanks, guys.
Thanks, everyone.
Bye, guys.